Welcome back my dear friends and dear students. A very good morning, good afternoon, good evening to all of you wherever you are in this part of the globe. And this is the DADM 3, which is Data Analysis and Decision Making 3 course under NPTEL MOOC series. And this total course duration in the week numbers is 12 weeks, and total contact hours is 30 hours, which is spread over 60 lectures, which means that each lecture is for half an hour. And as you can see from the slide, this is the last lecture of the 10th week, which is the 50 lectures, and after that you will take the 10th assignment. Before that you have already taken 9 assignments, and you will complete in totality 12 assignments, and then at the end of the lecture of 12 weeks being over, you will take the final examination. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, if you remember in the 47th, 48th lecture, we discussed a branch and bound for the integer programming. Again I am highlighting few points. It was purposefully taken as in a 2-dimensional case, as that we can show the graph and solve the problem as we proceeded, but I did not show the branches, which was very obvious. I could have done, but I did not show. In the next problem, which was a little bit more enhanced, it was a binary programming problem, but the main issue was that it was on a higher dimension, such that drawing the diagrams would not be possible. So, I basically highlighted the overall branch and bound the steps, and I also mentioned that I will give you the overall picture, the total solution, but at each and every stage where we are and from where we have come in the branch and bound method, I will highlight it using the different color scheme. Number 1 is from where we have come, and what we have already traversed would be blue in color, and where we are from the stage where we will go into the next branches would be highlighted by the green color. So, now when we left the 49th lecture last slide, it was basically trying to highlight one of the arms, which was basically the branches considering the actual binary variable binary formulation was given, and then we will basically now relax it, write the linear programming part and proceed accordingly. So, relax problem when we solve, which is branch number 3, is basically when we are taking, we have already taken as x2 as 1. So, x2 could have been 0 and 1. So, we take x2 as 0 now, and the LP relax problem formulation is like this. You maximize 9 plus 6 x3, and here you have the object the problem formulations as 5 x3 is less than equal to 4, and x3, which was initially binary, is now been relaxed and is continuous between 0 and 1. That is why this is the relaxed stage, which is given by this constraint. So, we will use it linear programming, solve it and find out the problem. So, once we solve the problem, the optimum solution comes out to be x1 is 1, x2 is 0, x2 is 0 based on the initial assumptions. X3 is 0.8, which was already considered, x4 is 0. The problem actual answer is 13.8. Now, let us see where we are, 13.8. So, where we have traversed are blue. Let me do it. So, we started from the actual tree. We have taken this route, found out a solution which was integer, very interestingly, with integer variables, binary variables. We have already traversed it, this portion. We have found out that the answer values for the decision variables were 2 were binary, 2 were non-binary. Then we took this route, and that I will highlight using green color, and where we are I will again highlight using the green color. So, the z value, as I mentioned, is 13.8, and the x1, x2, x3, x4 values are corresponding, and x5, x4 values are correspondingly 1, 0, 0.8 and 0. Now, here if you see that we would be taken the values, if you remember, I did highlight a few minutes back or in the last lecture, that the values here, they were x2 was non-binary, x4 was non-binary, Now, we have taken the values in a way that now we have to branch depending on the x 3 value. So, the x 3 values what we are going to take in the branches, one is x 3 is 0 and another is x 3 is 1, and we will basically try to find out which values it gives us the best answer, based on which we will basically find out the solution for that. So, we are in this green stage. So, branch 4 x 3 is 0, x 3 is 1 as I mentioned, and we consider x 3 is 0. So, x 3 is 0 is going in this direction. So, this one we will highlight this as green in the next slide when we check the branch and bound. Then this green one which is given here will become blue. The optimum solution for which we get for z, okay, by the way, we are solving this problem using the simple linear programming concept. The optimum solution z is 9 and x 1 is 1, x 2 is 0, x 3 is 0, x 4 is 0, which means that here x 1, x 2, x 3, x 4 are all binary variables which are plausible, feasible, and they are right as we have formulated the problem. The z value is 9. So, here it is, z is 9 and x 1, x 2, x 3, x 4 are 1, 0, 0, 0. Now, here I want to pause. There is nothing to do with the problem formulation as such, but check here very interestingly, this was just an outcome of the problem. I will use the red color and the pen. So, see here the value which you are getting here z9 and x 1, x 2, x 3, x 4 as respective values of 0, 1, 0, 1, and this also z as 9, the respective values of x 1, x 2, x 3, x 4 as 1, 0, 0, 0 is a very interesting fact we will compare later on. So, this I wanted to just highlight as a matter of fact as we proceed to the problem, nothing to do with the general branch and bound technique as such. The optimum solution z is 9 and as I mentioned x 1, x 2, x 3, x 4 values are respective 1, 0, 0, 0. So, now we have reached here. So, we will basically mark those points from which you have already visited as blue and where we are as green. So, we have already visited. So, we have already visited we have already taken this route, visited. Now, we have taken this route green and we are here. So, we will traverse back and then follow this. So, we have to basically come because other branches are still left, other branches like x 3 is 1, x 2 is 1. So, those are to be traversed and we want to basically check them. Now, we consider the branch number 4. Why 4? First one, second one, technically this should have been fifth one, third, fourth, fifth. So, we are trying to basically go for the fifth one. When we traverse the fifth one, this problem is not feasible because if you put as x 3 as 1 and the corresponding values as for x 1, x 2 and x 4 as 1, 0, 0, you do not get any feasible solution. I did not write it. So, obviously, this would be a non feasible solution, which we will see. Sorry, I basically jumped the gun and wanted to show the macro picture already. So, this is infeasible and we are here. So, I will highlight. So, we are now here. So, from where we have already come, I will highlight is blue. I am going a little bit slow, but please bear with me. already visited this place. So, this is becomes blue. Now, at this stage we were following this green one, which was not feasible. So, we basically, so again I will traverse back and follow this route. Now, we go to the other branch where x 2 would be 1, the other binary one. Now, x 2 is 1, here it is written x 2 is 1, and the corresponding values which you are going to take are x 1, x 3 and x 4 would be already highlighted and already been differentiated accordingly. So, the problem formulation exactly the same. So, the problem formulation is like this. I will try write the objective function. It is like this. So, we have been considering many steps at a time slowly. 9, 5, 6, 4. So, x 2 is 1. So, this is 5, x 1 was 1 which was 9, 9 plus 5 is 14, this is 14, oh this is 3, sorry, and x 3 and x 4 remain. So, it is basically 14 plus 6 x 3 plus 4 x 4. So, this equation what was original one and this one are the same, which is fine. Similarly, we will basically check the constraints. So, what are the constraints? This is the slide 63, I will come back to that later. So, 6, 3, 5, 2. Six 1 plus 3. So, which is x 1 is 1 6, x 2 is 1 3, 6 plus 3 is 9. On the right hand side you have 10. So, take 9 to the right hand side, 10 minus 1, 9 is 1, which is right. So, this equation x 3 and x 4 remain the same. The first constraint and the constraint which is written are right. So, I will consider the second, third, fourth constraint. Second constraint is x 3, x 4 less than 1. So, x 1, x 2 not there. So, obviously, x 3, x 4 is less than equal to 1, which is fine. So, this is also right. Now, let us go to the third constraint. Third constraint is minus x 1 plus x 3 is less than 0, because x 1 x 3 are 0. So, obviously, 0 is less than equal to 0. So, obviously, third constraint vanishes. So, let us check. So, the third constraint has vanished. Come to the fourth constraint. The fourth constraint is x 2 and x 4. So, now for x 2 and x 4, x 2 is 1 and x 4 is basically in this problem. So, you take 1 to the right hand side, it becomes 0. So, x 4 being less than equal to 0 is not feasible. So, obviously, it will be out. So, actually x 1 x 2 are not there. So, in the case of binary problem, x 3 is 0 and 1, x 4 is 0 1. When you relax it, the relaxed constraint which is of more important for us to highlight is this one. So, you have a problem of LP problem formulation, you solve it. So, with x 2 as 1 and considering the LP relaxed problem, you solve it and you get the answers accordingly. X z is 16, x 1 is 1, x 2 is 1, x 3 is 0 and x 4 is 0.5. So, x 1, x 2, x 3 are fine, x 4 which is 0.5 which is not binary, we have to basically again branch it accordingly. So, where we are in the macro and the micro stage of the total picture, in the branch and bound, again I will highlight using blue and green color which have been mentioning time and again in order to differentiate from where we have come, where we are. So, we are here, which I will mark in is green. So, I will not mark it immediately. From where we have come, we will mark everything accordingly. Just 1 minute, 1 minute. X2 is to 1, right. So, we have already traversed traversed that means already visited this place, traversed. Now are at these, took this route, we are at this position. Now for x3 is equal to 0. Now if you remember, okay, by the way, why we are branching? Now the values of x1, x2, x3, x4 are respective as 1, 1, 0.5. So x3 can be either 0 and 1. So we will again branch out accordingly. So x3 is 0, x3 is 1, and other values of x1, x2, x3, x1, x2, x4 sorry are highlighted accordingly. So they would be traversed in this following way. So for x3 the previous optimum solution was 16 and the values of x1, x2, x3, x4 were 1, 1, 0 and 0.5 sorry, it was 16. So, is still feasible and there is still a optimum solution can be obtained from there. Feasible in the sense it is another feasible region if you are able to draw the feasible region graph. So, here I have just added it an extra. So, I will basically move in this direction. So, I basically I am here in this. So, I will basically highlight this as green. So, first I will mark the blue ones from where I have come already completed. Already traversed. I have already traversed this. I have already traveled here. I am now here. So, I use green color. So, in order to highlight. So, from here, so I will again come back and try to find out at x is equal to 3 is equal to 1 what is the situation. For x equal to 4, okay, by the way, here x4, x1, x2, x3 are 1, 1, 0 and x4 is 0.5. So, it can be 0 and 1. So, basically again I branch out this branch which I am going to highlight in the next slide. So, x4 becomes 0, x4 becomes 1. So, let us check. For x equal to 4, x4 is 4, the optimum solution is 14 when you solve it. So, this concept of trying to write the binary problem, it is linear relaxation, solve it, they are repeated time and after time. So, I am skipping it for the discussion. So, when z is 14, x1, x2, x3, x4 are respective values of 1, 1, 0, 0, which looks interesting because you have to basically check it. So, here we are at this position which is should be green. I will do it, I will color it green. From where we have come, I will first highlight the blue. blue, blue. I have already done all these things. I have traveled here. Travel means I have already visited this place by the solution method. I have traveled here, visited this place. I have traveled here, visited these places, and where I am is green. Is basically Z is 14 and 110. Now look at it. Here I will pause for 2 minutes, again nothing to do with branch and bound. I am trying to basically understand how things are at this stage. So I will use the red color highlighter pen. This was 9 for values of 0, 1, 0, 1. I am only repeating the values of x1, x2, x3, x4. So, it is 0, 1, 0, 1. This was also 9 with values of 1, 0, 0, 0. This is interesting value which z is 14, which is higher because we are trying to maximize, and the values are 1, 1, 0, 0, and we will check whether we can improve the problems accordingly. So, this was just a comparison I wanted to do. So, this is not, you will basically in your programming when you do it or when you solve it, you will be checking it stage by stage, but I wanted to highlight it accordingly. For x is equal to 3 is equal to 1, the problem has no solutions if you solve it. So, x 3 is equal to 1 here, this has no solution. So, there is infeasible region. So, here we are. So, now we are in this feasible region not being there. So, dead end. So, this would be green, others are blue. This is also blue, this is also blue, this is also blue. We have already visited these places, solved and found out the answers. We have already visited this place. These are the branches and they are bound. Where we are is here. So, we will be basically covering it accordingly. So, we are at this non feasible area fathomed and we have stopped. Now, finally, x 4 is 1. So, you have to traverse it. So, the best solution still now is z is equal to 14, x is equal to 1, x 2 is equal to 1, x 3 is equal to 0, x 4 is equal to 0. Now, if you go for x 4 is equal to 1, wait. So, x 4 is equal to 1. So, these are the, if you do it for x 4 is equal to 1, there is no feasible solution, and once there is no feasible solution, you have traversed all the combinations and stop. And I will basically highlight the whole area as now with yellow, and the paths followed I would not highlight by green or blue because we have already traversed it. The yellow ones will be highlighted which are actually feasible and which are contenders. This is a contender. This is a contender. Contender means contender for finding out your optimum solution, and this is contender. So, you will compare them, which I told you when you compare. So, these are not no more contender, they are not feasible, not fathomed. So, they will rule out and out of the system. So, you have started from the left hand side, proceeded accordingly and reach the branch and the nodes where any further progress is not feasible, not possible. So, once I highlight, this will be compared with amongst them. The best solution is when x 1 is 1, x 2 is 1, x 3 and x 4 are 0 0, answer is 14. So, with this I will end the 50th lecture, which is the last lecture for the 10th week. We have considered 2 branch and bound problems in 4 consecutive lectures in details. Hopefully, it is helpful for you. And in the next class, we will starting the 11th week, we will start with the quadratic programming and some of the solutions. We did give some results, but I will come to the details of the solution methods. Have a nice day and thank you very much.